Hey there guys, welcome to my walkthrough of the November 2017 Edexcel Higher GCSE Maths Paper 1, which is non-calculator. There will be lots of useful stuff down below in the description, so make sure you take a peek, including my playlist containing every higher past paper walkthrough, all in one place. Okay, let's do this. Okay, number 1, just about as nice a start as we could hope for. We're at 36 as a product of its prime factors. So that's when we use factor trees. So we start with 36. Now I'm going to say that 36 is 4 times 9. Neither one of those is prime. 4 though is 2 times 2. Nine is 3 times 3. So we can say that 36 is 2 times 2 times 3 times 3. Which would be fine here because they didn't ask for it in index form, but we can clean that up as 2 squared times 3 squared. Okay, number 2, forming and solving an equation, and they've just chucked a bit of ratio in it for good measure. So, Kira is 7 years older than Jay. Martha is twice as old as Kira. The sum of their ages is 77. We want to find the ratio of Jay's age to Kira's age to Martha's age. Okay, so where do we start here? Well, both sentences about the ages contain Kira. So Kira is 7 years older than Jay. Martha is twice as old as Kira. So if we say that Kira is X years old, then if Kira is 7 years older than Jay, Jay is 7 years younger than Kira, which is X minus 7. And then we know that Martha is twice as old as Kira, so Martha is 2x. Now, if we add them all together, we get x add 2x, so that's 4x. And then we have the minus 7. Now we also know that the sum of their ages is 77, so we know that 4x minus 7 is 77. So now we want to solve this for x, so add 7. 4x is 84. Divide by 4, x is 21. So, now we know that Kira is 21. J is 14. And Martha is 42. So they then want the ratio of J to Kira to Martha. So J to K to M is 14 to 21 to 42. Now they haven't asked for it in its simplest form, so that should be fine, but there is a common factor of 7, so we could also write this as 2, 2, 3, 2, 6. Okay, number 3, some missing angle fun. So we got ABCD is a parallelogram, EDC is a straight line, F is the point on AD, such that BFE is a straight line, angle EFD is 35 degrees, angle DCB is 75 degrees. We want to show that angle ABF is 70 degrees. And we must give a reason for each stage of our working. Okay, so 4 marks. So the angle that we want is this guy down here. Now, first of all, we can say that this angle here is 35 degrees. Now I'm not going to write down the reason, just to keep time down. The reason for that is opposite angles. And then, because ABCD is a parallelogram, and this bottom right angle is 75 degrees, opposite angles in parallelograms are equal. So this chap up here is also 75 degrees. So now we're in a triangle in which we know 2 angles. So we can work out the third. Angles in a triangle add to 180. So 75 add 35. Is 110. So then finally 180 minus 110 is indeed 70 degrees. Cool. Okay, number 4. The diagram shows a logo made from 3 circles. Each circle has centre O. Daisy says that exactly 1/3 of the logo is shaded. Is Daisy correct? You must show all of your working. Okay, so we're gonna need the area of a circle, definitely. So area of a circle is pi times the radius squared. If you haven't yet, check out my formula video down below, from which you can get a printable PDF copy of all the formulas that you need. Okay, so what we're going to do is work out the area of all 3 circles. The shaded area is, well, we'll get into it. So let's first of all name our circles. So we'll call the small one C1, the shaded one, C2, and the outer one, so the whole circle, C3. Okay, so C1 has a radius of 4, so the area of C1 is pi times 4 squared, which is 16 pi. Okay, then C2 has a radius of 7. So C2 is 49 pi. And C3 has a radius of 10. So the area is 100 pi. Okay. So we can work out the shaded area. It's C2 minus C1. So the shaded area is 49 pi minus 16 pi, which is 33 pi. Centimetre squared. Now, if that's the shaded area, then the fraction that is shaded, so let's say the shaded fraction is 33 pi over 100 pi, which is 33 over 100. Now that is not 1/3. So we were asked, is Daisy correct? The answer is no. So in the real thing, make sure you put no. Okay, number 5, grouped frequency table. So the table shows information about the weekly earnings of 20 people who work in a shop. So we got their weekly earnings in grouped intervals and the frequency on the right. But work out an estimate for the mean of the weekly earnings. Okay, so when you have a grouped frequency table, and there's more examples of this down below in the description, we first of all need the midpoint of each interval. So we call that M. So the midpoint of 150 to 250 is 200. And then 300. Okay, so it continues like that all the way through, so 4, 5, 600. Okay, and the next thing we do is multiply the frequency by the midpoint. So we'll call that MF. So 1 times 200 is 200. 11 times 300 is 3,300. 5 times 400 is 2,000. 0 times 500 is 0. And 3 times 600 is 1,800. Okay, so now we add those numbers together. So 200 add 3,300 is 3,500. Add 2,000 is 5,500. Add 1,000 would be 6,500. Add 800 is 7,300. So that is our estimate for the total earnings of everyone who works in this shop. So that's £7,300. Now we were told that 20 people work in this shop. So to find the mean, we do 7,300 divided by 20. Okay, so there's a common factor of 10. So this is 730 over 2. And then we can use the bus stop for that. 2's into 7 go 3 times. 1 remainder. 2's into 13 go 6 times. 1 remainder. 2 into 10 goes 5 times. So we get £365. Okay, then for part B, Nadia says the mean may not be the best average to use to represent this info. Do you agree with Nadia? You must justify your answer. Okay, so I would say yes, I do agree. And the reason being is that the 3 at the bottom end, so the 3 between 550 and 650, are really outliers. There's no one between 450 and 550, so those 3 at the bottom are outliers. They are going to skew the mean. So yes, we do agree with Nadia. Okay, number 6. Here is a rectangle with a width of y and a height of 2x add 6 or 5x minus 9. So because it's a rectangle, those two must be equal. All measurements are in centimetres. The area of the rectangle is 48 centimetres squared. We want to show that y is 3. Okay, so again here, a bit more forming and solving equations. So what we can do is, first of all, find the value of x, which then allows us to find the height, which then allows us to find y. So we know that 2x add 6 and 5x minus 9 are the same. So we say then that 2x add 6 is equal to 5x minus 9 . Okay, so we now need to solve this for x. So if we take away 2x from both sides, we get 6 is 3x minus 9. If we then add 9 to both sides, we get 15 is 3x. And divide by 3, we get 5 is equal to x. Okay, so now that we know what x is, we can find what the height of the rectangle is. So 2 times 5 add 6 gives us 16 centimeters. So remember that we know the area of the rectangle is 48 centimeters squared. So we now know then that y centimeters times 16 centimeters is 48 centimeters squared. Divide by 16 centimeters and we get y is 3. Cool. Okay, number 7. Brogan needs to draw the graph of y equals x squared add 1. Here is her graph. Personally, I thought Brogan was a dude's name, maybe not. So there's her graph. We want to write down one thing that is wrong with it. So that is that she has joined the points with straight lines. She should have freehanded it because it's a curve. Okay, number 8. One says to write these numbers in order of size, starting with the smallest number. So we've got 0.246 recurring, so that's going 0.2464646 forever. 0.246 recurring, so that's 0.2466666 forever. 0.246 recurring, so that's 0.246246 forever. And then we've just got 0.246. So that last one is the smallest one because it stops. Okay, then the next one is going to be 0.246 with the dot above the 2 and the 6, because the next digit after the 6 is a 2. Okay, then the next one will be the first one, because the next digit after the 6 is 4. And then the last one is cool. Okay, number 9. 5 mark, speed, distance, time, fun. So for this, we're going to need to know that speed is distance over time. Okay, so quite a bit of information here. So James and Peter cycled along the same 50-kilometre route. Straight away, write down D is 50 kilometres. We're told that James took 2.5 hours to cycle the 50-kilometre route. Peter started to cycle 5 minutes after James started to cycle. Peter caught up James when they had both cycled 15 kilometres. James and Peter both cycled at constant speeds. Work out Peter's speed. Okay, so what can we do? Well, first of all, we can work out James's speed because he took 2.5 hours. So James's speed is 50 divided by 2.5. Now, that might not look very nice because you're dividing by 2.5. Here's a nice trick. Because it's a fraction, we can multiply the top and bottom by any number we want. Let's do by 2 here. So we get 100 over 5. Hopefully that's a bit nicer. That's 20 kilometers per hour. Okay, so now we know James's speed. We know Peter started to cycle 5 minutes after James. That's not really helpful yet. What is helpful though is that Peter caught up with James when they had both cycled 15 kilometers. So from that, we can work out how long it took James to cycle 15 kilometers. Then from that, we can work out how long it took Peter. From that, we can work out Peter's speed. So, speed is distance over time. If we want time, hopefully you've seen formula triangles. So here we would have S, T, T. Cover up the one that you want, and it leaves you with the formula. So time is distance over speed. So the time for James to cycle 15 kilometers is 15 divided by 20. Now that gives us 3/4 of an hour, which is 45 minutes. So that tells us then that Peter went 15 kilometers in 40 minutes because he started 5 minutes after. So Peter made 15 kilometers in 40 minutes. Okay, so we now need to turn 40 minutes into an hour. So 40 minutes is 2/3 of an hour. So we can say that 2/3 of an hour, or, well, let's just find 20 minutes. Let's not get fractions involved. So 20 minutes would be 7.5 kilometers. There's 3 lots of 20 minutes in 60, or we could just add these two together. So he's going to make 22.5 kilometers in 1 hour, so that is speed. Cool. Okay, number 10, indices. So my playlist is down below. 10a wants us to write down the value of 100 to the power of 1/2. So the power of 1/2 means a square root. So square root of 100 is 10. At B wants us to find the value of 125 to the 2/3. Okay, so using the rules of indices, we can split this power. So we can say that we've got 125 to the 1/3 squared. The powers on opposite sides of brackets multiply together. So 125 to the 3rd means the cube root of 125, which is 5. So we have 5 squared, which is 25. Okay, number 11. 3 teas and 2 coffees have a total cost of £7.80. 5 teas and 4 coffees have a total cost of £14.20. Our mission is to find the cost of 1 tea and the cost of 1 coffee. So, this is simultaneous equations. The way that we know that is we got 2 sentences about the same 2 unknown things. So, first job is to write each sentence as an equation. So, funnily enough, I'm going to use T for tea and C for coffee. So, we know that 3T add to C is £7.80. And we also know that 5T add 4C is equal to 1420. Okay, so the aim with simultaneous equations is always to get 2 equations with the same amount of the same letter. So here we can turn 2C into 4C quite nicely. So call the equations 1 and 2. Now to turn 2C into 4C, we need to multiply it by 2. So we multiply the whole of equation 1 by 2. Now that's going to give us 6t add 4c is equal to, well, 2 times 7 is 14, 2 times 8p is £1.60, so it's 1560. Call that equation 3. Okay, so now that we have two equations with 4c, we can get rid of the c's. So the way that we do that is by subtracting one equation from another. So to avoid negative numbers, I'm going to do 3 take 2. So 6t minus 5t is 1t. 4c take 4c, c goes bye bye. And then 1560 minus 1420 is £1.40p. So that is the cost of 1t. Okay, so now that we know that, we can substitute that into one of the equations. So I'm going to put it into equation 1. So we know that 3t add 2c is 780. So 3 times 1, 40. Well, 3 times 1 is 3. 3 times 40p is £1.20. So that's £4.20. Add 2c is £7.80. So if we take away £4.20, we get 2c is £3.60. Divide by 2 and we get c is £1.80. Boom. So 1 tea is 140, 1 coffee is 180. Okay, number 12, we have some box plot fun. So the table shows information about the heights in centimetres of a group of year 11 girls. So we know the least height, the median, the lower quartile, the interquartile range, and the range. Part A wants to draw a box plot for this information. So we need to work out two things from the table. So we know the least height, the median height, and the lower quartile. So the least height is the very left vertical line. The lower quartile is the left of the box. The median goes inside the box. What we need to work out is the upper quartile and the highest value. So, interquartile range is the upper quartile minus the lower quartile. So, that means the upper quartile is the interquartile range and the lower quartile. So here, that's 161, add 7. which gives us an upper quartile of 168. And then we do the same to get the greatest value. So we do the range. Range is the biggest value minus the smallest value. Here it's called the least, but same thing. So biggest, the smallest. So the biggest is the range add the lowest. So here, that's 20 add 154. Which is 174. Okay, so on our box plot, as I said, this guy on the left is the smallest value, the least height. The next vertical line is the lower quartile, then the median, and then the upper quartile, and then the greatest value. So that's part A. Part B is a box plot with information about the heights of a group of Year 7 girls. And part B wants us to compare the distributions of height of the Year 7 girls with the distribution of height of the Year 11 girls. Now it's 2 marks, so we need to be making 2 comparisons. So, first one I would go for is that the Year 11 girls have a higher median, so that means in general the Year 11 girls are taller, as you would expect, so that would be one comparison. And then the other I would say is that the Year 7s are more spread out, so they have a more diverse distribution of heights than the Year 11s. Cool. Okay, number 13. A factory makes 450 pies every day. The pies are either chicken or steak. Each day, Milo takes a sample of 15 pies to check. The proportion of the pies in his sample that are chicken is the same as the proportion of the pies made that day that are chicken. So, for example, if 1/3 of the pies baked on a day were chicken, in his sample, 1/3 of the 15 would then be chicken. So he would sample 5 chicken pies. On Monday, Milo calculated that he needed exactly 4 chicken pies in his sample. Part A wants us to work out the total number of chicken pies that were made on Monday. Okay, so if he needed 4 chicken pies in his sample, that's 4 out of 15, which means 4/15 of the pies were chicken. So we need to find 4/15 of 450. So, we can't see it easily, we could use the plus stop to find 1/15. So 15 doesn't go into 4. Carry the 4. 15s into 45 go 3 times. And then 15 into 0, not happening. So 1/15 of 450 is 30. We then want 4/15. So, sorry, yes, 4/15. So 4/15 is 4 times 30, which gives us 120. Cool. Okay, then for part B, on Tuesday, the number of stick pies Milo needs in his sample is 6, correct to the nearest whole number. Milo takes a random pie from the 450 pies made on Tuesday. Part B wants us to work out the lower bound of the probability that the pie is a stick pie. Okay, so he calculated he needed 6 pies to the nearest whole number of pies. So if we think about the error interval for the number of stick pies, so we're going to work an S in the middle. Now the lower bound would be 5.5, and that's the one we're interested in. So that's the lower bound that he could have calculated for the number of stick pies he needs in his sample. Now the upper bound, which is always a strict inequality, would be 6.5. So the lower bound for the probability, so let's call this P with an L, would be then 5.5 out of 15. Now, we don't like decimals in fractions, so even though that's right, they might cry. So if we multiply top and bottom by, I don't know, 2 or 10, whatever, let's do it by 2. And we would get 11 over 30. And that is the answer. So in the mark scheme they have 165 out of 450, or equivalent. This is equivalent to that. Okay, number 14. So they found another way to make ratio look quite scary. So the ratio y add x to y minus x is equivalent to k to 1. From that, we want to show that y is equal to x times k add 1 over k minus 1. Okay, so the first thing we need to do is turn the ratio into the form where it has a 1 on the right hand side. Then whatever we have on the left is what k is, because it will be in the same place. So if we have y add x to y minus x, to get the 1 on the right, we divide both sides by y minus x. So we get y add x over y minus x to 1. So that fraction is now in the same place as the k. That means k is equal to that fraction. So k is x add 1. No, sorry, what am I about? y add x over y minus x. Okay, so we now want to rearrange this algebraic fraction to make y the subject. I have a video on this, so if you want more examples, check out the link down below. Okay, so if we multiply through by the bottom, we get ky minus kx is equal to y add x Now we're trying to make y the subject, so we want to get all the y terms on the same side together. So I'm going to subtract y. So I'm going to get ky minus y. Now I also don't want this x term on the same side as the y's. So I'm also going to add kx to both sides. So I get equal kx add x. Right, now both sides can be factorised. So ky minus y factorises to y times k minus 1 and kx add x factorises to x times k add 1. And then the final step is to divide the bracket on the left away. So finally we get y is x times k add 1 over k minus 1. Boom. Okay, number 15 we have recurring decimals to a fraction. So I got videos on this, you know where they'll be, check them out. So x is 0.436 recurring, so that means 0.436363636 forever. We want to prove algebraically that x can be written as 24 over 55. Okay, so let's start off then with x is equal to 0.436 recurring. Now what we first of all need is we need a number with a purely recurring decimal. So at the moment that isn't purely recurring because 4 isn't recurring. So if we multiply by 10, we're going to move the 4 out the front. So we get 10x is 4.36 recurring. Now we need another number with exactly that same recurring decimal. Now because it's going 36363636 forever, if we multiply by 100, then we're still going to have exactly the same recurring decimal. So we now get 1000x is 436.36 recurring. Now we can lop off the recurring decimals using subtraction. So 1000x minus 10x is 990x. And on the right, 436.36 recurring minus 4.36 recurring is 432. So, now to get rid of the 990, we divide 3 by it, so x, let's do it over here. So x is 432 divided by 990. Okay, so now we need to simplify that. How lovely. So, top and bottom are at least both even. So we can divide the top and bottom by 2. So on top, we're going to get 216. Now 990 divided by 2, well, 900 divided by 2 is 450, and then 90 divided by 2 is 45, so it's 495. Okay, at that point, it's not really very nice. Both top and bottom have a common factor of 3. How do I know that? It's because the digits of each number add up to something 3 goes into. So 2 add 1 add 6 is 9, and 4 add 9 add 5 is 18. So when the digits of a number add up to something 3 goes into, it means 3 goes into that number. So if we do 216 divided by 3, 3 doesn't go into 21, 3 doesn't go into 2, but it does go into 21 7 times, and into 6 twice. So the top is 72, and then do the same with the bottom. 3's into 4 go once, 1 remainder. 3's into 19 go 6 times, 1 remainder, and then 3 goes into 15 5 times. So on the bottom we have 165. Okay, 3 goes in again. Now 72 divided by 3 is 24. And 165 divided by 3 is 55. That is what we wanted to show. Good times. Okay, number 16 we have proportion. So my playlist is down below. So we are told that y is directly proportional to the cube root of x. When y is 1 and a sixth, x is equal to 8. We want to find the value of y when x is 64. Okay, so first of all, if y is directly proportional to the cube root of x, the first thing we should write is y is proportional to the cube root of x. Now the formula that we're going to use then is y is k times the cube root of x. Now we need to find the value of k. So we know that y is 1 and a sixth when x is equal to 8. So x is 8 and y is 1 and 1/6. Now we're probably not going to want that as a mixed number, so turn that into an improper fraction. That's 7/6. Now, if we substitute those in then, we get 7, 6 is equal to k times the cube root of 8. Cube root of 8 is 2, so 7, 6 is 2k. Now that means then, if we divide both sides by 2, 7, 6 divided by 2 is 7 twelfths. So k is 7 twelfths. So that now tells us then that y is 7 twelfths times the cube root of x. Now, we were asked to find the value of y when x is 64. So, x being 64, it's going to give us y is 7 twelfths times, well, the cube root of 64 is 4, so we have 7 twelfths times 4. Now when you multiply a fraction by a whole number, it's just the top times the number, so that's 28 twelfths. Which is 7 thirds. Now they haven't asked for it in a specific form, but we could write that as 2 and a third. Okay, number 17 is some algebraic proof. So I have a playlist, you know where it is. So n is an integer, so a whole number. We want to prove algebraically that the sum of 1/2 n times n add 1 and 1/2 n add 1 times n add 2 is always a square number. Now it's only 2 marks, which I think at GCSE is pretty stingy, but there we go. So there is a quick way to do this, but it's probably just going to look scary, so what I'm going to do is what I recommend you do is expand everything and then simplify. So the sum means to add them together. So 1/2 n times n add 1 is 1/2. Now if we multiply the n's through, we're going to get n squared add n. Now that then is 1/2 n squared, which I prefer to write as n squared over 2. If you prefer to write it as 1/2 n squared, do that. And then n over 2. Okay. So then for 1/2 n add 1 times n add 2, so let's expand the brackets first. So make sure you can get n squared, add 3n, add 2. So that then is n squared over 2, add 3n over 2, add 1. So then the sum is n squared over 2 add n over 2 add n squared over 2 add 3n over 2 add 1. Okay, now we have n squared over 2 add n squared over 2. N squared over 2 means half of n squared, so if you're adding half n squared to half n squared, you have 1 whole n squared. And then very similarly, we have half an n add 3 halves of an n. Altogether, that's 4 half n's, so that's 2 whole n's. So we have n squared add 2n add 1. Now that can be factorised to n add 1 times n add 1, which can then be written as n add 1 all squared. So that is a square number, so it's always a square number. Cool. Okay, number 18, we are enlarging this triangle. So enlarge triangle P by scale factor minus 1/2. So a negative scale factor means the shape is going to end up on the opposite side of the centre of enlargement. So we're enlarging it with a scale factor of minus 1/2 with centre of enlargement O, 0, 0, which is the origin, and label our triangle Q. Okay, so lots of people find enlargements really tricky, which is a shame, but I do think it gets taught in a very strange way. So let's see if I can make this make sense. So first of all, 0, 0 is there. So that is the point with reference that we are enlarging. So we're going to do this point by point. So first of all, I'm going to use this point here. So how many places away from the centre of enlargement is the blue cross? Well, it's 2 right and 3 up. So because we are enlarging with a negative scale factor, we're going to be going left and down from 0, 0 and half the distance. So we're going to go 2, no we're not, we're going to go 1 left and 1.5 down. So that's going to take us there. Now let's do this point. Now this guy is 4 right and 3 up. So it's going to be 2 left and 1.5 down. So that's going to be there. And then the last guy, so he's 2 across, 2 right and 7 up. So for this guy we're going to go 1 left and 3.5 down, like that. So those are the 3 points of our triangle. In the real thing, use a ruler And don't forget label Q. Cool. Okay, number 19. So I'd say this is probably where the really fun questions start. So ABCD is a rectangle. A, E and B are points on the straight line L with equation x add 2y is equal to 12. We are told A and D are points on the straight line M. We are told AE is equal to EB. So this part of line is the same length as that part. We want to find an equation for M. Okay, so I would say this is probably one of the trickiest questions on the paper. There's lots to do. So, first of all we need to work out, well, what information do we have? What can we do with it? So we know the equation for L. Now it's probably not really in a form that you like using. So if we rearrange this, we get 2y is minus x add 12. And then divide by 2. Y is minus x over 2 minus half x, whichever way you prefer to think of it. So I write it minus x over 2 add 6. Okay, so from that, remember the general equation of a straight line. Y is equal to mx add c. M is the gradient, c is the y-intercept. So the gradient of L, which I'm going to call M with an L, is gradient, is minus 1/2. Now from that, and the fact that we know this is a rectangle, that tells us that L and M are perpendicular. Now, when lines are perpendicular, their gradients multiply together to minus 1. So from that, we can say that the gradient of M times minus 1/2 is equal to minus 1. So if we divide by minus 1/2, or if you prefer to think of it maybe as multiplying both sides by minus 2, we get the gradient of M is positive 2. So up to here, we can now say then that M is of the form y equals 2x add c. So how do we then find the value of c? Well, to do this, we need to know a set of coordinates that lie on M. So how in the world do we do that? Well, we need to go back to line L. Now remember that A, E and E, B are the same length. That means that E is the midpoint of A, B. So, if we find the coordinates of B and E, we can find the coordinates of A. So remember the equation of L is y is minus x over 2 add 6. Now, at point B, we know that y is 0 because we are on the x-axis. So that means then that minus x over 2 add 6 is equal to 0, or 0 is minus x over 2 add 6. So if we add x over 2, x over 2 is equal to 6. So x is equal to 12. So the coordinates at B are 12, 0. So that means then we actually now know the coordinate, or the x coordinate of point A. Remember that E is the midpoint, which is 12 left of B, so A is 12 left of E. So the x coordinate at A is minus 12. Now we need to find the y coordinate at B. At E. So we know the x coordinate here is 0 because we are on the y-axis. So when x is 0, y is equal to minus 0 over 2, which is just 0, plus 6. So y is 6 at E. Now again, E is the midpoint, so it's 6 up from B, so A is 6 up from E. So the y coordinate at A is 12. So we now have a pair of coordinates, minus 12, 12. We can find the value of C. So we now know when x is minus 12, y is 12, so we get 12 is equal to 2 times minus 12, so minus 24. Add C. So C is 36 and M as equation y equals 2x add 36. Cool. Okay, number 20. So this is a pretty big one as well, which also relies on knowledge of exact trig values. Now I've done a brand new video on that, which is linked down below. So if you don't know how to work them out, check out that video. So the table shows some values of x and y that satisfy y equals a cos x add b. Our job is to find the value of y when x is 45. So to do that, we need to find the values of a and b. So looking at our table, when x is 0, y is 3. When x is 30, y is 1, add root 3. So what would be really nice here is if, for one of these values of x, cos was equal to 0. Now, cos is, we have a look at the graph quickly. Cos looks like that. So when x is 0, cos is 1. Now, when x is 90 and 270, the cos function is equal to 0. So, in the table, we do actually have a value when x is 90. So when x is 90, y is 1. So that tells us that so when x is 90, y is 1. That tells us then that 1 is equal to a cos of 90, which is a times 0, add b. So that actually tells us that b is equal to 1. So we now know that y is a cos x add 1. So now we need to find the value of a. So cos of 0 is quite nice. Cos of 0 is 1. So let's say when x is 0, the value of y is 3. So that tells us then that 3 is equal to a cos of 0, which is a times 1, so just a, add b, which is 1. So, from that, a is equal to 2. So, now we know then that y is 2 cos x add 1. Okay, so we now need to find the value of y when x is 45. Now, one of the exact trig values, or the exact trig value for cos of 45 is root 2 over 2. Again, if you don't know how to work those out, check out the video. So, when x is 45, y is going to be 2 times root 2 over 2. Add 1, which is 2 times root 2 over 2 is just root 2. So we get root 2 add 1. Cool. Okay, number 21, we have some fun with surds, so I have a massive playlist on these, check it out. So we want to show that 6 minus root 8 over root 2 minus 1 can be written in the form a add b root 2, where a and b are integers. Okay, so what we're doing is rationalising the denominator. So, when you have a 2-term surd denominator, we use the difference of 2 squares. So, because we have a root to minus 1 down there, we're going to multiply the top and bottom by root to add 1. Now, when you do the difference of two squares, you always get the first term squared minus the second term squared. So, on the bottom, we are going to get root 2 squared, which is 2, minus 1 squared, which is 1. So on the bottom, we get 2 minus 1. Now the top might be a bit trickier, so I would always recommend using a table to do these. So we're doing 6 minus root 8 times root 2 add 1. Okay, so 6 times root 2 is 6 root 2. Root 2 times minus root 8 is minus root 16, which is minus 4. 6 times 1 on a good day is 6. And 1 times minus root 8 is minus root 8. Okay, so from that, at the moment, we have 6 minus 4, which is 2. We have add 6 root 2 minus root 8. Now we can simplify root 8, so we can write this as 2 add 6 root 2 minus root 4 root 2. Now root 4 is 2, so we have 6 root 2 minus 2 root 2, so altogether we have 2 add 4 root 2. So that's what we got up on top. Now on the bottom, of course, 2 minus 1 is just 1. So our final answer is 2 add 4 root 2. Cool. Okay, number 22, a pretty tricky similar triangles question. So the two triangles in the diagram are similar. So the two triangles that we have A, C, D, which is the overall big triangle, and A, B, E. So those are our two triangles. We are told there are two possible values of x, which might seem a bit strange. We want to work out each of these values, and we want to state any assumptions that you make in your working. Okay, so the reason that there are two solutions for x is that we don't know whether the side AC corresponds to the length AB or AE. So those are our two possibilities. Now we're going to go through each case separately. So first up, I've made separate sketches of the two triangles. So the lengths on the big one are these guys added together. So the length AC is 8 add x, and the length AD is 12 add 3, which is 15. So, to get a scale factor, we divide the length of the big shape by the length of the small shape. So, the first way around that I'm going to do it is with the two bottom lengths corresponding and the two left lengths corresponding. So, this side corresponds to this side. Okay, so to get the scale factor then, in this case, we do 15 divided by 12. Now that simplifies to 5/4, which is 1.25. From that, we then know that 8 add x is 1.25 times 8. Now that means one whole lot of 8 add a quarter of 8, so that's 8 add 2, so that's 10. So 8 add x is 10, which means then that x is 2. So that's case 1. In terms of writing down assumptions, really we've just assumed here which side corresponds to which side. So you would probably want to include saying something like that. Okay, let's do case 2. Okay then, so this way around we're saying that AD, so this length corresponds to AB, so that length. Okay, so in this case, our scale factor is 15 divided by 8. So that's not really very nice, but in this case, if those two sides correspond, then we know the other two sides that correspond together is 12 and the 8 add x. So 8 add x is on the bigger triangle, so that would mean then that 8 add x is 15/8 times 12. Lovely. So 8 add x is, now again, when you multiply a fraction by a whole number, you just multiply the top by the whole number. Now I'm going to do something a little bit different here. I'm going to think of 15 as 5 times 3, 3 times 5, and then 12 as 3 times 4. Now the reason I've done that is because we then got a common factor between the top and bottom of, where's that 4 come from? So there's now a common factor on top and bottom of 4. So we're going to get 8 at x is 3 times 5 times 3 over 2, which is 45 over 2, which is 22.5. So if 8 add x is 22.5, take away the 8, and we would get x is 14.5. Cool. Okay, then final question. So a nice big 5-mark quadratic inequality. Good times. So I do have stuff on these down below. So we are given a rectangle and a right-angled triangle. All measurements are in centimetres. The area of the rectangle is greater than the area of the triangle. So that sentence is where the inequality comes from. We want to find the set of possible values of x. Okay, so first step, let's find each of these areas. So for the rectangle, so call it AR, area of the rectangle, it's x minus 1 times 3x minus 2. Okay, so if we expand that, make sure you can get 3x squared. Then we're going to get minus 5x, add 2. Cool. Okay, then the area of the triangle, well, we know the base and the height, so it's base times height divided by 2. So x times 2x is 2x squared, divided by 2 is just x squared. Okay, so we know then that 3x squared minus 5x add to the area of the rectangle is greater than the area of the triangle x squared. Okay, so whenever you're playing with quadratics, you always want everything on the same side, 0 on the other. So we need to take away the x squared, and we get 2x squared minus 5x add 2 is greater than 0. So we now want to know the range of values of x for which this quadratic is greater than 0. So the way we do this is by plotting the graph and finding the values of x that create the part of the graph above the x-axis. So we now really think about it as an equation in terms of finding the graph. So we're now going to say 2x squared minus 5x add 2 is equal to 0. Now we're going to solve this, and what that finds us are the points where the graph cuts or crosses the x-axis, and that then allows us to plot the graph. So hopefully we can factorise it. So because we got a 2x squared, we're going to need a 2x. And an x in the second bracket. Okay, now we have a positive 2 at the end, but a negative number in the middle. That tells us both numbers are negative. And they have to multiply together to give us 2. So there aren't many numbers that do that. It's just 1 and 2. So together minus 5x. We're going to need a 2 there, so then that's going to give us minus 2 times 2x, which is minus 4x, and then minus 1 in there. So, when you solve quadratics, you then set whatever is inside the brackets equal to 0 and solve for x. So, if 2x minus 1 is equal to 0, add the 1, 2x is 1, divide by 2, x is 1/2. Or if x minus 2 is equal to 0, x is equal to 2. Okay, so that now tells us that the graph is going to look something like that. Now, it's good practice as well. We also know the y-intercept is 2. Not really important, but like I say, good practice. So we know the x values are 1/2 and 2. Now the inequality that we are solving is the quadratic greater than 0. So that means we want parts of the graph above the x-axis. So we want this tail and that tail. So the x values that produce those parts of the graph are x is less than 1/2 or x is greater than 2. Now then, even after all that, you might think we've definitely earned all 5 of these marks. You'd be wrong, apparently. So, have to be careful when you do this sort of question. If x was, well, it can't be 1/2. If it was just less than 1/2, or anything less than 1/2, x minus 1 would be negative. Now that doesn't make sense because it's the length of a rectangle. So only one of our solutions counts. So x cannot be less than 1/2, x can only be greater than 2. And there we go guys, we have finished. So I really hope you found this useful. Don't forget to get subscribed, give us a thumbs up, buy a t-shirt if you're really awesome. Good luck in your exams, take it easy, take care, have a great day.